Hello humans. Okay, let's show you how to do some finite element analysis in Inventor. So here I've got a assembly. This is the claw of the robot arm that you may be familiar with if you are studying mechanical engineering at London Southbank University. So I've put this together. You've got some screws and the other plastic parts, and they're all assigned the correct materials. If you just go to the material tool here, that's all okay. So I'm going to go to environments and click on stress analysis, and this will start your FEA. So the first thing you want to do is constrain this unit. You've got a few different options: fixed constraint, frictionless, or pin. Yeah, you need to choose the appropriate constraint for what you're performing the analysis on. But here I'm going to use some pin constraints because these are just going to be bolted in, and I'll do that in the 4 holes here. 3 holes. So that's all constrained, that's happy. And then just make sure again that all your materials are correctly assigned. If anything's missing, it'll come up with a little exclamation mark in the original material box here, and you just need to click on that part and you can change the material over in the materials toolbar. But that's all okay. So done that, then we want to put on some loads. There's a few different options here. You've got like bearing load, moments, pressure. I'm just going to put some force. I'm going to do this FEA as though it were sort of performing a pinching motion, and it was just applying pressure with this very tip of the claw. So I select the appropriate surface and select an appropriate magnitude. Something like 1.5 newtons is fine for a small metal object or whatever else. And then we can actually change the direction. You can see there that's not appropriate at the moment. So we click on a surface that is sort of like perpendicular to where that force is going to be applied, and you can change the direction up or down with that arrow. And so that's all happy. We've applied one force on that side, and I'm just going to repeat this and do the same thing on this side of the claw. So 1.5, make sure the direction's okay. There we go. So we have some force on either side of our claw there on those surfaces. So it's constrained, we've got the forces, the materials are automatically assigned. I'm just going to quickly click to mesh view, and you can see here it's pretty good at working out what an appropriate mesh would be. If I really cared, I could probably make this top mesh here a lower density, just to make the analysis a bit quicker. But you can see mostly like these big surfaces have this nice coarse mesh, and it gets finer for these smaller parts, so you generally don't need to play with that too much. And that's the main thing. There's a few more powerful things you can do in this tool, and I'd recommend exploring it. You can actually explore a few different sort of like parameters. You can say maybe, oh, I want this to be made out of plastic or steel, and you can do a comparison between the two. But for this project, you don't need to go that deep. So I'm going to click simulate now, and just click run to run the study. And you can see that study 1 of 1, because we're only exploring this instance where it's made of plastic and those forces are being applied. This takes a little bit of time, maybe slightly more for you, as I'm running this on a beastly system. Yeah, I would probably edit this out if I really cared, but I'm kind of doing this in 10 minutes, so I really don't. It's just computing the results. While it's doing that, I'll maybe just talk about a few of the options you have with your finished guide. It's often not obvious with any FEA, especially when you're looking at something like the von Mises stress, where the high points of stress are, because there'll be one. Oh, here we are, a good example. There'll be a few points where it's really extreme, but let's just change this back to the default settings. This is what that looks like when you've just finished your stress analysis. So you can see there's like a few occurrences of stress on the bottom of these bolts, but not much else. But you can actually fine tune that with the color bar. So make that red area, rather than the maximum stress experiences, something like 50 for now. So just half that result, and you can see that gives you a bit higher definition of where that stress is being experienced. And I'm going to take that right down to 20, just so we can get a clear view. And you can see that most of that stress is being experienced in this bolt here, and the surrounding bolts as part of the claw. The plastic that this is made out of is a bit more flexible. It's not going to experience stress so much, but it will experience some displacement, and it's worth just checking that out as well. You can see it gives you a good visual guide, much like ANSYS, which you'll be familiar with. It's exaggerated. Our max displacement is only 1.173 mil, so not very much at all. But you can see that there. And again, I'd recommend you play with the color bar if you're doing this to make a presentation. 0.5, apply. Just so you can maybe get a clearer view of that, and see where that's being displaced. There are some powerful tools as well. There's you can see stress and displacement in different axes if that's important to you. I'm not sure why it would be. You can also check out your strain. You see the strain there that's being experienced by the plastic, which may be useful to you in your presentation. And yeah, and that's it. So I hope that's been helpful. Please send me a message if there's anything you want to know, as usual. And yeah, good luck with your report.